Example 2. The city manager of Tilden wants to move the emergency siren so that it's the same distance from the school, the public library, and the campground. So, the school, the public library, and the campground, I'm going to say where these pins are represents the locations of those things. So the first thing I'm going to do is I'm going to draw lines representing the triangle. So, if I go from the library's pin across to the campground's pin, from the library's pin to the school's pin, off by just a smidge there, let me fix that. Again, if I'm the city manager of Tilden, I want to make sure I'm as precise as possible so I get this siren positioned in the right spot and make sure everybody's safe from the storms. And then from the city parks pin straight down to the school's pin like so. So I'm drawing a triangle to represent this problem situation. The circumcenter of the triangle represents the position that's the same distance from those three landmarks. So I'm going to perform the same construction just in example 1 on this problem. I'm going to bisect the segment from the library to the school first. Position my compass on the school, open my compass beyond halfway. I'm going to construct an arc on one side and the other side of that segment. Then I'm going to pick up my compass without changing the radius, put it on the library, and construct arcs that intersect those. One here and one there. And notice I almost missed that one. Again, I didn't, so that's good. If I did miss, I just need to come back over here, come back to the school, and then just, extend a little further. Obviously, on my board, it's not as easy to get in the same spot. You guys can get right in the hole that you made on the paper with the point. But just reposition and make it go a little longer if you need to. But again, as long as you can see that intersection, that's what you need. I'm going to take my straight edge and I'm going to connect those two dots. Again, connecting where the arcs intersect. All I'm looking at is the arcs. That's arc 1 intersection, there's arc 2's intersection. And I'm drawing a line through those 2 points. Like so. So that blue line is the perpendicular bisector of the line connecting the library to the school. Then I'm going to construct another perpendicular bisector. Let's do the perpendicular bisector from the school to the park. So if I bring my compass up here, again I want to open beyond halfway. Again, I can kind of visualize where halfway is, just go beyond halfway. I want to construct an arc above and below, so green. So here's my one side arc. Here's my other side arc. Then I'm going to pick up my compass, slide it over to the school. Turn my compass so I can intersect those arcs. So I got that one and that one. All right. So the green arc intersections represent the equidistant points from these two to make a perpendicular bisector. Then I simply take my compass again. I position it so it is going to intersect those 2 points where the arcs intersect. Might be as precise as I can here, so let's see. There we go, that's pretty good. So that's the perpendicular bisector of that segment. And the point where they both intersect is right here on the corner of South Elm and 4th Street. That point right there, we'll call it S for siren. That point is equidistant from all 3 locations. So if you were to go to the corner of Elm and 4th right now in Tilden, this is copied off of Google Maps, it's drawn to scale. The corner of Elm and Fourth is exactly the same distance from the library, the school, and the campground. You can tell people that if they're interested. And then, if I pick up my compass again, and I simply place it point on S, and I open up my compass to one of the three landmarks, I'm going to go to the school here, positioning it at the school, as you can see. Just a little bit bigger, maybe. That's probably about right. And if I draw a circle, you'll see that it pretty closely hits all 3 points. Again, experimental error. There's a big jump every time I move it. It moves a lot. So,
Mine's off by a little bit on Tristan Smith's side.
and again, this right here, if I were grading your paper, I'd say that's probably close enough. I'd like yours to be a little closer, but that's probably close enough.